our new material or the next set of material we have is chapter 6. And one thing, ladies and gentlemen, chapter 6 is just the backward operation of chapter 5. I want to tell you that, remember, in the beginning, if we teach you how to add, we have to teach you how to subtract. If we teach you how to multiply, we have to teach you how to divide, which is the opposite operation. And in chapter 5, if you remember, we distributive in, right? We have a parenthesis, we have some item, we distributive into our problem, or whatever our problem is, we try to distributive in. Now, from here on out, from chapter 6 and beyond, chapter 6, chapter 7, and chapter 11, what we will do a lot is we will factor out. We will factor out in the way of, basically, this is what we need to do is, whatever the problem that you have, now we ask ourselves, what can we extract out? What can we factor out? Meaning, in terms of this item here, the GCF, which is the greatest common factor, they ask you if we give you 24x to the second minus 16. So if you look at this item here, you ask yourself, between 24 and 16, what is the greatest? What is the biggest divider? That's all they ask you is, between the two common number, what is the biggest divider that can divide into 16 and into 24? Or in a way that, if you look at this thing here, this is what I break down. Or if you look at this item, we can break 24 by 8 times 3, and 8 times 2 will give me 16. Or in another word, A is the biggest divider, go into 24 and go into 16. And basically, whatever the biggest divider, all you need to do is, you do not throw it away. All you need to do is you extract them out. So looking at this item, the greatest common factor or the greatest common divider is 8. All we need to do is we extract the 8 out, and whatever the leftover is, we put them in the parenthesis. If you remember in chapter 5, and again, chapter 5, if you look at 8 open parenthesis 3x squared minus 2, that is the question in chapter 5. And the answer in chapter 5 is 24x squared minus 16. Okay, so that's the idea here is no matter what we give you, and let me give you, take a look at this. And like I mentioned to you guys, is in chapter 5, reminder, this is what we have in chapter 5, right? Chapter 5 is this problem here, 8 times 3x squared minus 2. This is what in chapter 5, and what do we do in chapter 5? In chapter 5, we ask you to distributive this thing in, right? And if you distributive this thing in, this is what we have is 8 times 3 to give me 24x to the second, and 8 times 2 to give me 16. So the reverse of chapter 5, where you distributive them in chapter 6, we ask you to factor out, okay? So whatever we do, we just extract them out. So no matter what the question we have, so for instance, we continue with example 1, and they ask you to factor out the GCF, greatest common factor. So how do we factor out a GCF? If I were to give you this problem here, for instance, let's say if I give you, let me make it easy, 25x to the third plus 15x squared minus 35. So no matter how big the problem is, all you ask yourself is this question, ladies and gentlemen. I have my first term, I have my second term, and I have my third term. In this case, this is a trinomial. In those terms, what is the biggest divider that I can find? What is the biggest divider that can go into 15, 35, and 5? And many of you or all of you probably say, well, Mr. Tran, I know that 5 probably the biggest divider that can go into this item here, because most of you guys see that they all end up 5. So this is what I asked you guys last time, is whatever the divider is, you do not throw the divider out. All you do is whatever the divider is, you bring it to the outside, and whatever the leftover, you put in the parenthesis. So what is 5 going? Well, 5 going to 25 will give me 5. I still have x to the third. 5 going to 15 will give me 3. I still have x to the second. And 5 going to 35 to give me 7. And that's all they ask you to do when you factor something out. Ladies and gentlemen, this is all we're doing, is we factor them out by not throw them away, right? Your factoring is basically a divider. But instead of throw the divider out, whatever the common divider is, we just bring it to the outside. And this is our answer. Our answer will be 5 open parentheses x to the third plus 3x squared plus minus 7. Okay. So question here in terms of this small item. And one thing is, if you can see, I did not factor any x out. Why have I not taken any x out? Because this item here, because the 35 do not have an x. In order for you to factor anything out, ladies and gentlemen, in order for you to factor anything out, they have to be common in all 3 terms or in 4 terms or how many ever term you have. Okay, so if we take a look at B, and let's take a look at B, and let's say we have 36 x to the 4 minus 16 x to the second. Okay, so between 36 and 16, you ask yourself, well, what do they have in terms of a common divider? What is the biggest common divider you have? We know that 16, again, if you have two number, hopefully you see this thing here, ladies and gentlemen. If you have 2 number, you want to focus with the small number first, right? What is the multiple of 16? Well, we know that 16 can go into 16, but 16 cannot go in 36. So we know that we can X out the 16, right? The 8 can go in 16, but 8 cannot go in 36. So we X out the 8, right? 8 times 4 is 32, not 36. So we know that the 16 and 8 does not work. The next number, the big number we can see that some of you guys say is 4, which is, that's what the number we have. We know that 4 can go into both of them. 4 can go to 36 9 times, and 4 can go into 16 4 times, right? So that's one thing, is we looking for the biggest divider for the constant. Now, do you agree that I have an x over here and an x over here? So for the x, the easiest thing to do is x, you take out the smallest exponent. What is the smallest exponent between a second and a fourth power? We can see that the smallest exponent is x to the second. And again, the only reason I wrote it this way is to show you that all we're doing is we extract out the common divider, or in this case, the biggest divider. The common divider, yes, the 2 is a common divider, it's not the biggest, right? So this is all we're doing, is whatever you just see, whatever we just have, we do not throw this thing away. All we do is we bring it the 4x squared on the outside, and whatever left over is in my parentheses. What is the leftover? We see that 36 is 9 times. And if I took out 2 of the x, how many x do I have left in here? Do you agree that I have 4 minus 2? I still have 2 left. And vice versa on the back end, 4 going to 16 is 4. I took both of the x squared. I took it out. There's no longer an x inside. And again, if you look at inside your parenthesis, they do not have anything in in common, meaning they don't have an x that you can take out, and between the 4 and the 9, they don't have a common divider. Okay, so this is our answer in chapter 6. In chapter 6, this is our answer. And again, you say, well, Mr. Tran, in chapter 5, this was the question. Yes. You want to check, right? If you want to check your answer, you can always distribute it back. You can always distribute this item back, which is in chapter 5 on your midterm. You take this and you distribute, you see that 4 times 9 to give you 36, x to the second time x to the second, x to the 4. 4 times -4 to give you a -16, bring down your x squared. As you can see, this is our problem. If I erase all of this thing here, this was our problem in the sense of our original item. So as you can see, all we're doing is we do the opposite of what we did in chapter 5. Okay. So let's take a look at, let's see if I give you C. Same thing go, and let's say if I give you 48x to the 4th minus 12x to the 3rd plus 24x. So looking at this thing here, like I mentioned, each is one individual item. And if you have between 48, 12, and 24, you want to attack the smallest number first, right? Do you agree that 12 can go into 12? So we know that 12 can go to 12. In order to use 12, we have to ask ourselves, well, can 12 go into 24? Again, can 12 go into 48? So in this case, as you can see, 12 can go to all 3 of them, right? If 12 cannot go to one of them, then we go down in terms of the 6, right? Multiple of 12. So in this case, everybody see that we want to, for the constant, we want to look at the biggest divider. The biggest divider is 12. And now between my x, I have x to the 4, x to the 3rd, and a x to the 1, right? Simply x to the 1 power. So between the exponent, what is the smallest exponent that you can pull out? Everybody agree that the smallest exponent you can pull out is x to the 1 power, right? So basically this, ladies and gentlemen, we do not throw this away. That's your biggest, that's the biggest common divisor that we have, the greatest common factor that you can have. The only thing is we do not throw it away. Whatever the common divisor is, we bring it to the outside. And now, if you bring this to the outside, do you agree that 12 going to 48 is 4 times? And if I took out one of the x and 4 of the x is there, do you agree that I still have x to the 3rd power? And 12 going to 12 is 1 time. And if I took out one of the x, I still have 2x left. And no, it's not wrong if you put the 1 there, and it's not wrong if you don't put the there. Just put 1 there because I say 12 going to 12. And lastly, 12 going to 24. Do you agree that 12 going to 24 is 2 times? And I took the x out, there's no longer an x left. And that is what we have here, ladies and gentlemen. This is the greatest common factor. The GCF is 12x. But we do not throw it away, we factor them out, we extract them out. So question, would A, B, or C here? Now, if you don't have question, let's practice this thing here. Let's say, what if I give you this item here, D? And let's say if I have x to the 4, y to the 7, minus 2x, y to the 11. Let's say if I ask you to factor out a GCF, right? the G. So how do we factor out a GCF? And the purpose of this problem here is I just want to tell you guys is all we're doing is no matter what X or Y do we have, first of all, the constant, there's nothing in terms of the common constant, right? So we know that there's an X on this side and there's an X on this side, and vice versa, there's a Y here and there is a Y there. So we know that there are X's on both and Y's in both. And if you remember what a bit earlier, all we is for your X or your Y, for your exponent, you look at the two and you take out the smallest of the exponent. Between my X, what is the smallest of the exponent between my X? Do you agree that X to the 1 power is smaller than X to the 4? And between my Y, do you agree that Y to the 7 is smaller than Y to the 11? So basically what you do is you ask yourself between your exponent, what is the smallest of the exponent? Whatever the smallest of the exponent, you bring it to the outside. And if you bring it to the outside, what is left over? Well, if we have 4 of the X here, and I bring out 1 of them, do you agree I still have 3 left? I no longer have the Y because I have only 7, Y to the 7. I took all of them out. There's Y on the first item. And I haven't done anything with the 2. And if I took 7 of them out, do you agree I have 3 of the Y left? Or in the sense, this is our answer here. And if you want to break down, right? If you want to break it down, or whoever say, wait, Mr. Tran, how do we take it out like that? Well,
for Y, isn't it 4?
4,
Mr.
yes,
Tran, for Y, isn't it 4?
4. Sorry. Yes. If you want to break it down, take a look at this item here. Do you agree that X to the 4 is the same as X times X times X? And Y to the 7, I should use a smaller number than this. Y times Y times Y times Y, right? And the second item I have is 2 times X, and then again Y times 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 Y, 11 of them, right? And again, basically all this group, and in the set, do they have in common? Well, in of them, they have an X in common. That's why you take out 1X. And if I take out 1X, everybody see we have 3 left here. And in the second one, I have 7 of them, which is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. As you can see, on the first item, in the first group, I only have 3 left. And in the second, Y, which is Y to the 4 power, right? And again, the 2, I haven't done anything here. And that's what facts do, ladies and gentlemen, is they ask you, what do they have in common? And whatever they have in common, all you need to do is extract them out. So question here in terms of this item, in terms of the GCF. Now, let's take a look at example 2. Example 2, same thing go, they ask you to factor out, factor. And let's say if they give you something like this. Let's say they give you 2 times X plus 4 minus X times X plus 4. Let's say they give you this problem and they ask you to factor out or factor. How can we factor this item? One thing is I want to point out, ladies and gentlemen, is please do not think in terms of any distributive anything as of now, okay? When we distributive, last time we did in chapter 5. Right now, the only time that you think in terms of distributive is when you want to check your answer. Okay, don't distributive the 2 in the parentheses, don't distributive the x squared, don't distributive anything in. Okay, your distributive is in chapter 5. Now your goal is you want to factor out. So when you factor out, this is what you need to ask yourself. I have the first item, 2 times x plus 4. I have the second item, x squared plus 4x. Now, between my 2 items, do I have anything the same? Anything exact? Do you agree that I have x plus 4 item and x plus 4 the second item? And if I have it exactly the same, all I need to do is take it out because they are common. And if they are common, I can take this item out. And whatever left over, I just put in another parenthesis. So what is in another parenthesis? Do you agree that if I took x plus second item, I still have an x squared? And this, ladies and gentlemen, is all that they ask you to do. All that they ask you to do is look at the 2 items you have. Look at the 2 items you have and which one, or do they have anything in common? If they do have something in common, if they don't have anything in common, you cannot. So in this case, do you agree that we have something in common? And if they have something in common, we just extract them out. Or vice versa, if we have, say, x squared times x minus 10 plus 7 times x minus 10. Same thing go as you can see. Hopefully you guys see that it's very simple. We have x squared times x minus 10. The second item, 7 times x minus 10. And between those common item. Common, if they are the same, all we need to do is bring the x minus 10 out. And whatever left over, once you bring it out, whatever left over, you just put them in one parenthesis. And this is all that they have, which is x minus 10 on the outside. And the leftover is x squared. I have x squared here, plus 7. Is what we need to do if we were to factor this item out. So let me give you another one and ask you guys to do this item here. Right? Let's say if I give you 5x times y plus 3 minus 7y times y3. Again, doesn't matter what the problem is. All you need to yourself is, do I have something in common? I don't distribute anything in. Do I have anything in common? And hopefully you guys see that the y plus 3 and the y plus 3 is common item, right? They are the same. What do? We bring the y plus 3 on the outside. And if I bring the y plus 3 on I have y. And later, that is our answer. So you probably say, Mr. Tran, give me a lot of this problem, right? Give me a lot of this problem. I know how to do it. Well, one thing is, yes, I hope that you know how to do it. The reason why I give you this problem is this is the bridge to the second item in chapter 6.1. And the last thing in chapter 6.1 is this, ladies and gentlemen. Example 3, and they ask you to factor by grouping. So how can you factor by grouping? Well, let's take a look at the problem plus. And let's say plus square plus 3x plus 15. So this is, see, whenever they factor, this is what you see is you probably will see, well, you will always see 4 terms. And if you look at this, you can see that not factor. Why we cannot factor out any GCF? Because they don't have any common item, right? We have one item here is x to the third power. We have this item, x to the second, this item just x. There is no x here. That we cannot extract out an x. Between the 3 and the 5, they don't have a common divider. So looking at this thing here, we kind of stuck, right? We kind of stuck in a way that they don't have a GCF. They don't have the greatest common factor. But what do we do? So one thing is this, ladies and gentlemen, whenever you have this 4, all you need to do is follow the direction, right? The direction tells us that we need to factor out by grouping. And to group this thing, all you need to do is take the first 2 and put in a second group, okay? So we group the first 2 items and we group the second 2 items. And the do this is this right here. Do you agree that if I give you 3 plus 4 plus 5 plus 6 is the same as 3 plus 4 plus 5 plus 6? Do you agree that if I put them in the parentheses, it does not change? 3 plus 4 is 7. 7 plus 5 is 12. And do you agree that 12 plus that will give me 18, right? And if you add this thing here, well, 3 plus 4 is, this thing will give me 11, 18. So as you can see, I can group them because addition is associative and commutative. The order doesn't matter and the grouping doesn't matter, because when you add them, the result is the same. You change the look of the problem, but you're not changing the solution. Everybody see that? And with that, we can group this together the way that we do it here. We just group the first 2 and group the second 2, okay? So now, once you group them, this is what you ask us. X to the second power and x to the third power, meaning what can I extract out? What can I take to the outside? Do you agree that I can take x squared outside? Be x, I take a small, and here I take x squared, and if I take x squared, do you agree that I still have 1x here? Have a, because x squared times x to the 1 power will give me x to the third, and x squared times 5 to give me square. And in group, do you agree the second group, I can take out a 3, or in this item, the common divider is 3. And if I take out a 3, do you agree that 3 going 3 will give me an x, and 3 going 15 will give me, and look at the item here. Is this item similar to what we have up there? Do you agree that what we have x, those are my common item, and those are my common item, do you agree that I can take out x plus 5? And what is my leftover? My leftover will be x squared plus 3. If I take x plus 5 out, my leftover is x squared plus 3. And ladies and gentlemen, this is our answer. If you put x squared plus 3 in front and x plus 5 in the back, doesn't matter, you will get the same answer. Okay, so again, one thing is, I know this is the first time you see it. Let's take a look at another one, and then I will take your question. Let's take a look at B. And let's say if we have similar problem, let's say x to the third power, plus, let's do plus 11x squared plus 4x plus 44. And again, if you have this problem, the first thing you need to do is, well, the direction will tell us that we need to factor out by grouping. This thing here, all you need to do is group the first two and group the second two. That's all you need to do is in the first item, take the first two items, put them in one group, take the second two items, put them in another group. And then one individual item and group as a second individual. So in the first group, do you agree that in the first group, you can take out an x squared? Because between x to the third and x squared, I can take out x squared. Do not have anything in common, right? X to the second time x to give me x to the third, x to the second time 11 to give me 11 x to the second.
Mr. Trang, I don't know if it's with everybody else, but you're cutting out a lot on my end. So why do you take out x to the x squared?
Because x squared, because this is the common that they have in this group. This is the remember, between the exponent, smallest exponent is what we can take out.
Wait. Listen, Mr. Trang, you're cutting out really bad, and I think it's other people are saying the same thing. So you're cutting out like as you're talking. So I'm not understanding you.
Okay, let's see. Give me 1 second. Okay. Is it better now? Is it better now?
Yeah, it's better. You're not cutting for me now.
Okay. So one thing about this here, ladies and gentlemen, let me move to this item here. I think it's because of my iPad. And when I try to connect with the iPad, is the connection is weak. So basically, remember, in order for you to take the exponent, remember your exponent is between the two exponents. We want to take out a smallest of the exponent, right? So last time on the previous problem I have, I have this item here. Let me.
I didn't complete that item either because I couldn't understand you, so I had no clue what you were doing.
Which problem we are looking at?
Just the one we're on, and just the last one is the one that I'm stuck on. Okay. Everyone else I was okay with.
Okay, so take a look at, let me type it up. Let me get out this thing here.
I'm just having the issue with example 3, factor by grouping. I understand where you group them into two groups, but then how you do it afterwards thereon is where I'm a little confused.
Give me 1 second here. So the previous problem we have is this, right? X to the third power plus 11x to the second power plus 4x plus 44, right? So this is what we have. And let me delete this. Let me delete all of this thing here. So in order for you to do this, we know that this is what we need to do is we need to group them together in terms of x to the third power plus 11x to the second and 4x plus 11, not 11, 44. Agree?
Yes.
So now in the first group, in this group right here, now you need to ask yourself between those items, between this item, x to the third and 11x squared, what can you extract out? What do you have in common? Well, the only thing in common is, if you look at this thing here, the only thing in common is, do you agree that we have 2x in common, right? This thing here is x times x plus 11x and x and x, which in this case, do you agree that the only thing that they have in common is this x here and this x here? And if that is the only thing that they have in common, do you agree that I can take out the 2x and the leftover is x plus 11? And instead of write 2x, do you agree that it's just basically x squared?
Okay.
Do you agree that that's what we have in terms of the first group, in terms of x to the third plus 11x squared? And that's why I told you is between the exponent, we just ask you ask yourself between the exponent, what is the smallest of the exponent? And whatever the smallest of the exponent, that's what you bring it to the outside, and that's what I bring it to the outside, which is x.
You subtract it from the other one, and whatever's left over, you use it in the parentheses.
Exactly.
Okay.
Right.
Okay.
So again, 3 minus 2, I still have 1 left. 2, I took it, again, this thing here, I took it everything out. That's why there's nothing left here, which is I only have 11. So everybody still with me in terms of the first parenthesis?
Yes.
Now, in the second parenthesis, I don't want red. In the second parenthesis, back home. It's not. In the second parenthesis, do you agree that this is what I have? Right? And let me change this thing to white. So between the 4x and the 44, what do they have in common? Do you agree that 4x I have in common is the 4?
Yes.
So what can I bring it outside? Well, this is what I can bring outside. I can bring outside a 4. And if I bring outside 4, do you agree that 4 over 4 is just basically simply an x? And 4 going to 44 will give me 11. Agree? And now, ladies and gentlemen, at this step right here, this is what you end up with. You end up with this item here. And at this step, I want to point out that your parenthesis, hopefully you guys see that in your parenthesis, this is what you need to see, or this is what you need to have, is they need to be exactly the same. If they are not the same, if your parentheses are not the same, you did something wrong, or I give you the wrong problem. But mostly you did something wrong, okay? Just kidding, but look at this thing here. At this step, everybody see at this step right here, your goal is the thing inside your parentheses have to be the same. And if they are the same, all you need to do is take that parenthesis out. Everybody see that I took out my parenthesis. So if I took out my parenthesis, whatever my parenthesis is, in this case, I took out my parenthesis, so x plus 11 is out. And if I take out x11, what is left over? Do you agree that the leftover, whatever my leftover is, I put in another parenthesis, which is x squared plus 4. And that is our answer. X plus 11, x squared plus 4. Okay, so one thing is, like I mentioned, at this step right here, at this step, whatever this step is, your goal is you need to have the same exact item in your parenthesis. If they are not the same exact item in your parenthesis, you did something wrong. Okay, so let's take a look at, let's try one more. Let's try another one, and hopefully let me see. So let's take a look at, let's do this thing here. Something go, let's say, let's change it up. Let's do y. Let's say y raised to the third power. Let's do minus this time. Minus 9y squared plus 4y. No, I don't. We did 4 already. 6y minus 54. Okay. So if you look at this thing here, again, doesn't matter if it's x, doesn't matter if x or y, this is what you have. This is all we've seen is this item here.
I can't hear you.
And again, can you hear me now? Y to the
Can't
third
hear
power?
you. Can't hear you. Can't hear you.
I can hear him perfectly fine by me.
I don't know. I can't.
Is
I can
everybody
hear
hear me
you
now?
now. I can't. Yeah, I'm sorry. I don't know what happened. I couldn't hear you. I'm sorry.
All right. So once we have this, ladies and gentlemen, once we have this, do you see that doesn't matter it's X or Y? All we're doing is we take the first 2 items and we put them in one group. We take the second 2 items and we put in the second group. That's all we're doing here is we take the first item, we put in, again, no, this, let's make it blue. We take the first 2 items, put in the first group, take the second 2 items, put in the second group. Now we just treat the first group as one item, right? We ask ourselves between the y to the third and the y squared, do you agree that the only thing they have in common is the y because they have no other number? Between the y to the third, y to the square, what can you extract out? Do you agree that you can extract out y to the second? Because whatever the smallest exponent, that is what you take out. And if you take it out, do you agree that 3 minus 2, I still have 1 y left? And if I took out y squared, do you agree that this item here is what I have is y minus 9? Everybody still with me here in the first group? Now, in the second group, between y, 6y minus 54, we know that they don't have a y in common, but what do they have in common? Do you agree that there's a 6 and a 54? Meaning, do you agree that they have a common divider? What is the common divider here? Do you agree that the common divider here will be a 6? Because 6 going to 6 is 1 time, or in this case, y. And 6 going to 54 is 9 times. Everybody still with me here in terms that this is what I factor out. I factor out a y to the second power. I factor out y to the second power. And I factor out a 6 on the second item. And do you agree? Do you agree that this item, y minus 9 and y minus 9 is the same? And ladies and gentlemen, at this location right here, you need to have the exact same item in your parenthesis. If you don't have the exact same item in your parentheses, like I mentioned, we did something wrong. Okay, and if they have, or if you have something exactly in your parentheses, what do we do? All you need to do is take your item, in this case, y minus 9 outside, and what is left, if you took that out, well, the leftover will give me y to the second plus 6. Everybody see that if I took this thing out, right? If I took this thing out, y minus 9, I took it to the outside, y minus 9, I took it outside. Do you see that I have a leftover of the y to the second, which is in blue, plus 6? And that is my answer in terms of this item here. Y minus 9, y squared plus 6. Question? Any question here, ladies and gentlemen? Well, I'm running out of time, so let's take a let's stop here for today. We will pick up more of this